Once again, welcome back to my channel, Easy and Inspire. In previous class, we have seen what is a register, what is the need of register, and different types of registers like all these four. In today's session, I am going to discuss about serial input and serial output register. Listen, SISO register. Just go through this heading carefully. Serial input and serial output. So this is my register and it is having input output. These two are in series with the register. See, both are in series, so not parallel. So serial input and serial output. And I am considering here 4-bit register. Listen carefully. 4-bit register. 4-bit register is having 4 flip-flops. 1, 2, 3, 4. So 4 flip-flops. So it is used to store data like 4 zeros or 0001 or and so on up to 1111. So you can store whatever the data you want in this register because it is only 4-bit register. Okay. So now I'll show in this session 4 ones. I'll store this data. Okay. Just observe this one. And clock pulse. It is very, very important because all the registers are synchronous sequential circuits. Synchronous means there is a clock pulse. Okay. Synchronous sequential circuits. This clock pulse plays very important role in this shift register. So I'll explain. Just wait. Now I'll explain how it is going to be operated. Please pay attention here. Don't get confused and you will get full clarity in next slides. So just I'll explain briefly. 1, 1, 1, 1. This is my input. So this one is input to the first flip-flop. Only when clock pulse is applied. Listen carefully. So you can consider either positive going edge or falling edge. We know this is rising edge. All these are rising edges. You can consider falling edges also. Here I am considering only rising edges. When this pulse is applied, then this input is applied here and it produces output here. Listen carefully. It produces output here. Okay. So whatever the output, it is presented here. Consider it is 1. Okay. Next, at this point, so during the second clock pulse, this input is going here and it produces some output. Pay attention. This second one is going to be input to the first flip-flop and it produces output. Already there is one output here. This is going to be input for second flip-flop and it again produces output. So in series, we are applying input in series and output is also shifting like this in series. So this is the operation. Finally, whatever the data you are entering at input side, see, this is my data. So after first clock pulse, so output is appeared here. After second clock pulse, so output is appeared here and here. After third clock pulse, output is appeared here and here and here. So like this. After 4 clock pulses, see, after 4 clock pulses, output is produced here. So after 4 clock pulses, okay, just please remember how it is going to be propagated. So data is shifted like this. Okay. So observe this point here. First in, first out. This is the main process here. So first in, first out. See, 1, 1, 1, 1. First in. So it is going to be propagated like this, like this, like this, and it is first output. Similarly, second input. Similarly, third one. and then fourth one. So first in, first out. This is what we observe in SISO. Okay. Now I am going to explain serial input and serial output register by considering D flip-flop. See here, I am going to explain this register using D flip-flop. If you don't know the operation of D flip-flop, just watch this video and then observe this register. Okay. So D3, D2, D1, D0. These are inputs to the flip-flops and Q3, Q2, Q1, Q0 are outputs. Initially, without any input and without any clock pulse. Listen, without any input and without any clock pulse. Then it is nothing but reset condition. All the outputs are zeros. So, if you are applying an input here, please 1, 1, 1, 1. So, input is applied and clock is not applied. So, again, it is not going to produce any output because it is a synchronous sequential circuit. Clock is necessary. If clock is not applied, it is not at all going to produce any output. Please remember this one. And this input I am applying to this flip-flops and how output is going to be obtained. I'll explain the operation. Please pay attention. This is my first stage of operation. Initially, without applying any clock pulse and without applying any input signal, this is our output. Okay, default output. And we are going to give this one 4 ones as input to this register. Okay, first of all, see here red color. This is nothing but LSB. I am going to give LSB bit as input to this one. Okay, this is my LSB bit. Okay, I am coming from here. Okay, so for this flip-flop, input is 0 because this output is given as input to this one. 0 is input. So D flip-flop is data flip-flop. It is going to produce the same as output. Okay, next one. For this one, see, for this flip-flop, this is my input. And again it is going to produce the same. Okay, next for this flip-flop, this is my input. See, 0 is my input. It is going to produce the same 0 here. So it is going to produce 0, it is going to produce 0, it is going to produce 0. And now for this flip-flop, input is 1. So it is going to produce 1 as output. So 0 is gone and now it is 1. 1, 0, 0, 0. This is my output after applying first clock pulse. See here. Why I am mentioning first clock pulse? Because first clock pulse 1 is applied. Positive clock pulse is applied here. Okay. So clock pulse is applied to all these flip-flops. But 1 is applied to this flip-flop only. So 1 is obtained here. Clock is applied and initially 0. So 0 is produced. Clock is applied, 0 is input, 0 is produced. Clock is applied and 0 is input, 0 is produced here. Remember one point here. If clock is applied, okay, if clock is applied and if it is 1, then it is going to produce 1 here. Don't get confused. Clock is must for any flip-flop to operate. That is the main point here. Clock is must to operate. So here my output is 1, 0, 0, 0. So this is not the one. This is just an example. 1, 0, 0. So after first clock pulse, so my output is 1, 0, 0. Initially it is 4 zeros. Okay. Now we'll go for second phase. This is second stage of operation. Already first clock pulse is applied in previous slide. Now I am going to apply my second clock pulse, this one. So I am taking only positive rising. See here, positive going clock pulse or rising edge clock pulse. Okay, and this one is already applied. Now I am going to apply this one. See, red color one. Okay, so now previously 1, 0, 0 is our output. See, I am going to explain here. 1 triple 0 is our output previously. Now for this flip-flop, input is 0, clock pulse is applied. So it is going to produce output 0. For this flip-flop, input is 0. So pay attention here. For this flip-flop, input is 0. Again it is going to produce output 0. For this flip-flop, input is 1 previously. So I have mentioned that one here. Input is 1. So clock is also applied. So it is going to produce 1 as output. And for this flip-flop, this one, see here, this one is applied here. For this flip-flop, this one is given. So it is also going to produce 1. So my output is 1, 1, 0, 0. 1, 1, 0, 0 is my output. So just remember one thing. After first clock pulse, output is 1 triple 0. After second clock pulse, so this input is applied to this one and it is coming here. So this is going here and these two are zeros. Okay, this is nothing but this one. Okay, 1, 1, 0, 0 is my output. After second clock pulse, you can take either positive going or negative going. Okay, so see 1 triple 0, these black color, all my inputs. Just I have mentioned once again by taking another zeros here. Don't get confused. Now, after third clock pulse, first clock pulse is completed, second one is completed, third one. So at this point, so my outputs, previous outputs are 1, 1, 0, 0. Okay. So now this one, see, this one is going to be applied as input to the first flip-flop. First means this one. Okay. So for this flip-flop, see, consider this one. Don't consider this one. These are outputs. These are inputs. So all these are my previous outputs. For this flip-flop, 0 is my input. See here, for this flip-flop, 0 is my input. So it is going to produce 0. For this flip-flop, 1 is input. So it is going to produce 1. For this flip-flop, 1 is input. So again it is going to produce 1. For this flip-flop, this one is given as input. Again it is going to produce 1. So 1, 1, 1, 0. 1, 1, 1, 0 is my output. See, this is my output. Okay. Now, last stage. So fourth stage. My outputs 1, 1, 1, 0. Okay. And now this one is going to be applied here. Always remember, 1, whatever the input we are giving, we have to give here because we are applying in series. So for this flip-flop, I am mentioning these are my inputs. Okay. For this flip-flop, 1 is my input. So it is going to produce 1. For this flip-flop, 1 is input. So it is going to produce 1. Again for this, 1 is input, output is 1. For this flip-flop, 1 is input and it is going to produce output. So all these are possible only when fourth clock pulse is applied. So I have considered only 3. So this means it is continued. Okay, at fourth clock pulse. So fourth clock pulse, my outputs are 1, 1, 1, 1. So after first clock pulse, 1 triple 0 is my input. After second, 1, 1, 0, 0. Third, 1, 1, 1, 0. After fourth clock pulse, 1, 1, 1, 1. This is how outputs are going to be changed. Okay. And see, Q3, Q2, Q1, Q0. So 1, 1, 1, 1. This is my output. My input is 4 ones. Output is 4 ones. Means it is stored here. So remember, input is 4 ones. Initially you have considered 4 ones as input. See, this is my input. And now this is my output. Means it is stored here. This is tabular representation of SISO. Okay. Initially, without applying any input and without applying any clock pulse. Initially, without applying any input and without applying any clock pulse, my outputs are, see, 4 zeros. First clock pulse is applied and input is given. So it is going to produce output. Okay. And T2 is 0. So Q2 is 0 because D2 is input, Q2 is output. So if you want, you can observe in here. D2 is input, Q2 is output. Okay. Similarly, D1 is input, Q1 is output. So it is 0. So it is 0. Again 0, it is going to produce 0. So this is the process. After applying second clock pulse, see, another one is given. See, 4 ones, right? First one is given here. Now second one is going here. So this one is given as input here, D3. So Q3 is same as D3 because it is transparent. Okay. And D2 is 1 here. See, D2 is 1. So Q2 is 1. Again 0. Again 0. Whatever the process we have done in previous, that is what I am going to represent here. After applying third clock pulse, this is my input and it is going to produce output here. So this input here and this is 1. Okay. So D2 is 1. So it is going to produce Q2. So similarly Q1, Q0. Similarly after fourth clock pulse. So fourth one is also applied here and outputs are 1, 1, 1, 1. So this is what my tabular representation is. Okay. And finally, so this is timing diagram. First clock pulse, second, third, fourth clock pulse. Initially, all my outputs are zeros without applying any clock pulse. 0. See here. So at this first clock pulse, output is going to be changed to 1 and remaining all are zeros. We know 10000 is output. After second clock pulse, 1110 is our output. After third clock pulse, 1110. After fourth clock pulse, 4 ones. See, here I am mentioning Q3, Q2, Q1, Q0. So 10000. Here 1110. Sorry, 1100, 1110, and this one 4 ones. So after 4 clock pulses, this is my output. Whatever the data we are entering, that is what we are getting. That is nothing but it is storing the data. So this is what a register means. SISO. In next session, I am going to continue the next type of register. Thank you.